All right, now we're going to look at a case of a geometric series, and we saw a lot of examples of this when we looked at logs and exponents with exponential growth and exponential decay, and now we're going to come back to compound interest. So compound interest is the most common kind of interest that you're going to find in loans or savings accounts, anything like that. And the way that compound interest works is that you earn money on all the money that's in the bank. So not the same amount every year, but you get more if you have more money. So same thing applies, that we start with our first amount of money. And then at the end of the first year, notice that if we multiply this out, this ends up being P, our initial principal, plus our principal times the interest rate. So it's the same thing as simple interest in the first year. But now in the second year, I get my P2 is equal to the interest that I get on this whole amount of money. So the reason that I did 1 plus R is because I'm getting 100% plus my interest rate. So all of my initial plus my interest. So now I'm getting interest on this whole thing. So P naught times 1 plus R, I get interest on all of that. So I multiply all of that times 1 plus R. So 100% plus my R. That ends up being P naught times 1 plus R squared. In the third year, I get my previous amount of money. I get interest on all of that. So here's my previous amount of money. Now I get interest on all of that. And I have P naught equals 1 plus R to the third. So I'm going to continue getting interest on all of my amount of money until my nth term. That means I'm going to end up with P naught times 1 plus R to the n. So I get interest applied n times. And that's because we started with our initial amount of money here at P0. So that's why this has n and not n minus 1. Because I applied the interest n times. Okay, so our annually compounded interest formula is, and this is what we saw back in our previous notes, that our balance is equal to our initial amount times 1 plus R to the n. And this is annually compounded. We'll look later at if we compound monthly or daily to see what happens then.